this video, we're going to go over the basics of how to solve combination circuit problems. The first step in all of these problems should be to combine whichever resistors you have that are in parallel. You'll do this by adding them together using the normal method for adding resistors in parallel, which is to take the inverse of their resistance, sum those values, and then take the inverse of that sum. For this problem, it is the 250 ohm resistor and the 600 ohm resistor. We'll take the inverse of each of these numbers and add them together, and then take the inverse of our answer to get their combined resistance value. We find that to be 176 ohms. We'll then rewrite this circuit as an imaginary series circuit that has 3 resistors instead of 4. The 250 ohm and 600 ohm resistor we will replace with their combined resistance value of 176 ohms. Now that we've combined our parallel resistors and rewritten the combination circuit as a simplified series circuit, we can find total resistance like how we normally do with series circuit problems. To do this, we simply sum up the resistance values of each of our resistors. In this problem, that would be 360 plus 120 plus 176 ohms. We find the total resistance to be 656 ohms. Now that we know the total resistance and the total voltage, we can find the total current going through the circuit using Ohm's law. We'll do this by dividing the total voltage, which is 110 volts, by the total resistance, which is 656 ohms. When we divide these values out, we find that our total current is equal to 0.168 amps. Since the circuit we're currently working with is a series circuit, we know that there's only one pathway for this current to flow through. Therefore, the amount of current flowing through each resistor must also be equal to 0.168 amps. Now that we know the amount of current flowing through each resistor, and now that we know the resistance value for each resistor, we could solve for the potential energy difference across each resistor, also known as the voltage, by taking the current values and multiplying them by the resistance values. For our first resistor, the one with the 360 ohm resistance value, we find that the potential energy drop across that resistor is 60.5 volts. For our second resistor, the 120 ohm resistor, we find that the voltage drop across that resistor is 20.2 volts. For our third resistor, the imaginary combined resistor that we're using to represent the 250 and 600 ohm resistors that were in parallel in our first circuit, we find that the potential energy drop across that resistor is 29.6 volts. We could double check that our voltage values are correct by summing them up. The sum of the voltage drop across each of our resistors in series should add up to be equal to the total voltage output by our power supply. The value may be slightly different due to rounding. We now have calculated everything we need to know about the 120 ohm resistor and the 360 ohm resistor. However, let's recall that the 176 ohm resistor was simply an imaginary construct we used to simplify the calculations for our 2 resistors that were in parallel in our original circuit. With our imaginary 176 ohm resistor, we know that it experiences a voltage drop of 29.6 volts. We also know that resistors that are wired in parallel experience the same potential energy difference. Therefore, the 250 ohm and 600 ohm resistors in our original circuit must also experience 29.6 volts of a potential energy difference across them. We also know that the 176 ohm resistor has a current value of 0.168 amps. We expect this to be the amount of current that is split between the 2 branches of our parallel section of our circuit. We expect that a greater amount of that current should travel through the branch of lesser resistance. In our case, that's the resistor with a value of 250 ohms. Our last step in our combination circuit problem is to solve for the individual amounts of current going through our two resistors that are in parallel. We can do this using Ohm's law, which is current is equal to the voltage, 29.6 volts, divided by the resistance, or 250 ohms. We then get a value of 0.118 amps. We could use the same equation to solve for the amount of current going through our 600 ohm resistor by once again taking the voltage of 29.6 volts and dividing it by the resistance. We get 0.0493 amps, rounded to 0.049 amps. These two amounts of current should sum together to equal the total current of 0.168 amps. Your value might be slightly off due to rounding, but it should be pretty close to the total current value.